A, B. So excellent. What does this probably say? 12, 13, 14. Okay, and you can see that the data that's entering I is the stuff in the middle. It's the same data, but you're giving it a different meaning based on its context. If I tweeted right now, my laptop is sick, what does that mean? My laptop is sick. Yeah, you're cool, aren't you? You'll get kids. If you're old and boring like me, it means it's broken. And so that sound that's going through your ears, that data can be interpreted in two ways. And if I ask you to read this and to picture in your mind what you think is going on, so I want you to read this sentence and construct an image in your mind of what is going on here. So does anybody tell me what's going on in their head? Anybody want to volunteer? What does this say? Sorry? A guy, John, reading a letter out loud to Mary. So actually this can be interpreted in many ways. John could be reading a letter that was addressed to Mary. John read the letter sent to Mary. John could be reading the alphabet A, B, C, D to Mary. John could be reading the letter of the law to Mary. John could be reading a book called The Letter to a lady called Mary. John could be reading a book called The Letter to Mary. John could be reading two words on a piece of paper, The Letter to a lady called Mary. You could read instruction, John, read the letter to Mary. This can be interpreted in many, many ways, and we will all go away with a picture in our mind of what we think is true, and we're probably wrong. And my goal today is to convince you all that humans are rubbish. That's my goal today. And anyway, so if I give you a spreadsheet, and in that spreadsheet it has 3 columns. It has a date column, a temperature column, dates, temperature, and the number of ice creams that I sold on that date. So date, temperature, ice creams. What ice cream sales? What do you do with that spreadsheet? What do you do with that information? It's not a trick question. Huh? Sort it, and then what? What would you do? Huh? Look for a correlation, so you could do statistics, or we could draw a graph. If we had increase in temperature along the x-axis, increase in ice cream sales along the y-axis, what does my graph look like? I know you can all do this, wave your arms around. We see, okay, so the hotter it gets, the more ice creams we sell. Excellent. This is called descriptive analytics. What we're doing is we're organizing information, find patterns to know things about the world. And we can do something really cool now. We can do a thing that everybody's excited about. We can do a thing called predictive analytics, and we can all put our line through it. So you can all do this in Excel. So you're all now data scientists. And now what we have is predictive power. So if tomorrow is 22 degrees outside, I can look at my model. I can see how many ice creams I need to manufacture. I now know things about the world. I know that as it gets hotter, I sell more ice creams. But actually, Plato had a very good definition for knowledge. He said knowledge is justified true belief. Justified true belief. So knowledge isn't facts. It's not information. Knowledge is based on our experience, our statistical experience. We believe something's going to happen. And we can get more and more complex. We can add more and more equations and use more advanced machine learning to get a better fit. And actually, I would argue that all we're trying to do in data science and machine learning is to fit some sort of line or plane or hyperplane to some sort of data set to give us the best predictive power. That's all that data scientists are trying to do. But knowing something is very different to understanding it. So can anybody tell me, why do we sell ice creams when it's hot outside? Why do we sell ice creams when it's hot outside? Okay, so let's take a step back. I'm inside. We're in the UK. It's hot outside. What's the first thing that happens in the UK? We all go outside. So it's a scarce resource. Then what happens? We get hot. Then what happens? We buy an ice cream. What do we do with the ice cream? Put it down our pants. What do we do with the ice cream? Huh? Eat it. And why does eating ice cream cool us down? Thermodynamics, exactly. Now, to expect a computer to understand this narrative from this line is impossible. It doesn't understand human behavior. It doesn't understand thermodynamics. Why it's really important to bring the domain experts, the people that understand the world, together, the people that are very good at finding patterns. Because your domain expert is going to say, Daniel, your model of the world here is wrong. Because if tomorrow is scorching hot, really, really hottest day ever, what's my factory going to do? It's break it. So it's not going to manufacture lots and lots of ice creams, right? But the fact is, if tomorrow is scorching hot, nobody's going to go outside and buy any ice cream. So the model of the world looks more like this. Very, very important we bring those two people together. That doesn't happen enough in industry, and we make lots of mistakes. Anyway, I would argue that we're trying to understand the world perfectly so that we make good decisions. And it turns out that humans are pretty bad at making decisions. So I'm going to try to argue that now. I don't know if you've read the book by Daniel Kahneman, Thinking Fast and Slow. Daniel Kahneman is a Nobel Prize winning economist. He argues we have a fast brain and a slow brain. And I'm going to try to illustrate some of these brains to you now because there are parallels in terms of how AI works. So I'm going to ask you some maths questions. I know it's late in the day, and your job is to answer these maths questions as fast as possible. If you don't answer them faster than your competitors, they're going to take your market, okay? Speed is important. Start out nice and easy. We're going to get more and more complicated. First question is, what is 2 times? Excellent, fantastic. What is 14 times? Okay, so this one you didn't even need to think about. It just came from your fast brain. This one you need to go through a process, an algorithm to come up with the right answer. Okay, ask you a few more maths questions. Again, we'll start out nice and easy. We'll get more and more complicated. Next one is the combined price of a bat and a ball is £1 and 10 pence. The bat is £1 more than the ball. How much is the ball? Anybody? Quickly, what's your fast brain say? 10 pence, yeah. It's not 10 pence. Don't worry if you said 10 pence. You're not broken. The bat is £1 and 5 pence. The ball is 5 pence. The combined price is £1 and 10 pence. The bat is £1 more than the ball. So this is where we used our fast brain, and we probably get a wrong answer. And I can give you thousands of these examples, and you get them wrong. Okay, so imagine these are 5 staff members. So you've got 5 staff members here. Imagine we know all their preferences, their skills, their superpowers. What we want to do is allocate these 5 staff members to 5 projects. Okay, how many ways can I allocate 5 people to 5 projects? Anybody know the answer to that? So I can see one allocation here. I can flip 2 around and get another allocation. How many ways can I allocate 5 people to 5 projects? Yeah? Remember that exclamation mark we learned in school, factorial, 5 times 4 times 3 times 2 times 1. There's 120 possible ways I can allocate these 5 people to 5 projects. Let's make the problem a bit more complicated. I've got 15 people I need to allocate to 15 projects. How many ways can I allocate 15 people to 15 projects? Don't say 15 factorial, that's cheating. What does your fast brain say? Guess? Guess? Okay, so it's over 1 trillion possible ways. So 15 times 14 times 13 times 12, lots and lots. It's a big number. To expect a human to solve this problem, I don't know how many people you have in your organizations, but I expect it's more than 5 or more than 15. To expect a human to solve this problem, we're wasting our time. If I had one rule to take away with you today, anything more than 7, don't use a human for. Humans are pretty good at solving problems up to 7. Resource allocation, whether it's allocating people to projects or vehicles to deliveries or marketing money to channels, anything more than 7, we're useless. And actually, industry don't have problems of this size, they have problems of this size. So here are 500 staff members. Can you tell me how many ways I can allocate them? It's a big number. It's a number that's got over 1,000 digits. And just to put this number into context, this is how many atoms there are in the universe. So once you reach about 60 things that you have to consider, 60 people, 60 marketing channels, 60 anything, you have more possible combinations than you have atoms in the universe. Humans can solve problems up to 7. You can hire a good computer scientist that can build an algorithm that can solve problems up to 30 or 40. Beyond that, we are pretty rubbish. And actually, you have to hire for a very, very specific set of skills that I'll talk more about later on. Oh, let's just drum this home. Imagine I've got my ice cream van, and my ice cream van has to deliver ice creams around these 24 points around London. And what I want you to do is figure out what the best route is around these points. So maybe after a few minutes, we'll say, well, I think this is the right route around those points. How long will it take a computer to get the best route, the one that's going to save the most amount of petrol, the most amount of time? How long will it take a computer to get the best solution? Milliseconds? Okay, we played this game already. It's 20 billion years. So if you put 20 times, so 24, 23, 21, into your calculator, you get this number. This is how many routes there are around those 24 points. If you had a computer that could check 1 million routes a second, that could calculate 1 million routes every single second, it would take longer than the age of the universe to go through every single possible one and say, this one I looked at 10 billion years ago, this one's the shortest one, you should do that. If I had another point to the map, I now have 25 times 20 billion years, 5,000 billion years. If I had another point to the map, it's 26 times 5,000 billion years. These are exponential problems. They get ugly very quickly. Just go back. One of my clients is PwC. They have 5,000 auditors they need to allocate to jobs. In WPP, we have 120,000 people to allocate to jobs, to projects. These are big, big problems. One of my clients is Tesco. They have 200,000 points on a map that they're delivering to every single day. 200,000. We don't have gazillions of years to optimize those vehicles to service those customers. You have milliseconds between each customer coming in to calculate those routes. So this is why algorithms are important. When I build systems for companies, they usually have these 3 parts: data, everybody's going on their digital transformation. They're spending lots of money on data lakes and SAP and all those companies. I think that's a very big mistake. But anyway, they think that by getting all of their data together in one place, they're going to be able to extract magical insights that's going to drive value in their business. Let me just give you 2 examples of why that's not the case. So a low-cost airline approached me a few years ago and said, Daniel, we're collecting all of this data about where people are clicking on our website and their purchase history. We know the name of their dog. We know what they're going to have for dinner. We want you to predict if they're going to churn, if they're going to go to another low-cost airline. And I said, well, why do you churn? Why do you go and buy for another low-cost airline? Why do you churn? Why? Cheaper. So I said, are you collecting your competitor pricing? And they said, no. If you don't give me that data, we're wasting our time. Give me the data that contains a signal. I'll give you another example. A short-term loan company wanted to predict if you're going to default on your loan. So this is where you borrow like £1,000 and you have to pay it back at the end of the month, otherwise you pay lots of interest. And they said, we're collecting their LinkedIn data, Facebook data, all of this social data. All of that data was useless at predicting loan default. There were 2 very good predictors. The first predictor was a font, a typeface that was kept in your internet cache. And that font is often found on gambling websites. So if you're a gambler, you're not going to pay back your loan. And the second predictor was the number of mistakes they made when they were filling out the application form. And that was an indication that they were intoxicated. So if you're drunk or high, you probably want to get money to get more drunk and high. So you don't have to have all of the data in the world to do anything interesting. You have to have the right amount of data that contains the signals. We're wasting a lot of time at the moment trying to get lots of data together. Anyway, everybody's hiring data scientists, machine learning people, my students, to try and find insights from data. I would controversially argue companies don't have machine learning problems. They don't have insight problems. They have decision problems. And decision making is a completely different field in computer science. They're hiring machine learning experts, data scientists to solve these problems. Actually, these people are discrete mathematicians, optimization researchers, logicians. There's probably only about 3,000 of these that exist really across the globe. It matured in academia about 2 decades ago. Everybody's going to be hiring for these. They're going to realize that these are not the right people to solve your problems. And then there's going to be another renaissance of these types of skills. I would always start out with what decision needs to be made, build an algorithm to solve that, then extract the insights to help make better decisions. And I see a lot of mistakes that companies are making in hiring in to try to solve that first. Anyway, if I build a system that I give data to, and tomorrow it makes a decision, and tomorrow I give it the same data, it makes a decision, I have automation. And automation is amazing because we can get these systems to do things way better than human beings. But does anybody know the definition of stupidity? What is the definition of stupidity? Huh? Doing the same thing over again, expecting a different answer. Okay, so by definition, automation is stupid. By definition, it is not intelligent. Everybody that currently touches this AI stack, this technology stack is calling themselves an AI company. That's fine. You get more clients, you get more VC funding. But there are 2 definitions of AI. The first definition is popular but terribly weak, which is getting computers to do things that humans can do. And the reason why it's popular is because over the past 10 years, we've managed to get machines to do things that traditionally only human beings can do. We can get machines to recognize that's a chair and that's a person and they're happy and she's sad. We can get machines to correspond in natural language, do chatbots and all that kind of stuff. But humans are very good at solving problems up to 7. We're very good at finding patterns up to about 4 dimensions. Computers can solve problems with thousands of dimensions, and they're infinitely better than human beings at making decisions. So benchmarking machines against humans is a very, very silly thing to do. There's a much better definition of AI that comes from the definition of intelligence. So rather than using humans as the definition of intelligence, there's this, which is goal-directed adaptive behavior. And in some respects, this describes marketing. We have a goal, we have an objective that we're trying to achieve, and I've just hopefully convinced you that most of those goals that we're trying to achieve are infinite in terms of their size. They're really, really, really big search spaces. Behavior is how quickly I can answer that question. And again, you need to have very, very good algorithms to be able to answer those questions very quickly. But the key word is adaptive. What we want to do is build systems that can make decisions, learn about whether those decisions are good or bad, then adapt themselves so that next time they make better decisions. And we do that in our industry. It's not fully automated. But if I was being brutally honest, I haven't seen a single complex adaptive system in production in my life. So actually, I would argue that nobody's currently doing AI according to this definition. That's not to say that this isn't coming. Organizations are trying to figure out how to architect themselves for adaptation. For the most part, most systems are autonomous. They make decisions and they don't learn from them. If you say to a CTO, I'm going to put a system in production that needs to make mistakes for it to get better, they say, no way is that going into production. If I say to a CTO, I need to put a system in production that's going to behave differently tomorrow than it will today, they say, no way is that going into production. Do you remember the Microsoft Twitter bot a few years ago that Microsoft launched the bot on Twitter? Lots of teenagers decided to tease the Twitter bot. It became a sexist, racist bot very quickly. That's what happens when you put systems in production that can adapt themselves. They can adapt in ways you can't predict. Anyway, building safe, adaptive systems is extremely hard, and this is the true paradigm of AI. A little bit of history. So this is one of my favorite paintings. It's Socrates before he drinks hemlock and kills himself. This was AI in the 60s and 70s. In the 60s and 70s, we would write down rules, and then we would try to infer new knowledge from those rules. So if I say to you, Socrates is a man and all men are mortal, I can infer that Socrates is mortal. And that's AI in the 60s and 70s. It didn't really work. And then in the 80s and 90s, a new type of AI came along that's modeled on how biology learns. This is the brain of a bumblebee. But my PhD 18 years ago was trying to take the brain of a bumblebee, which is 1 million neurons, by the way. Their brains can fit on the end of a needle, and trying to essentially model this brain in the machine. And 18 years ago, it was impossible to model 1 million neurons, but if you could, bumblebees do amazing ththings, by the way. They navigate 3D worlds, and they recognize objects, and they talk to each other, they solve problems. They don't handle windows very well, but ultimately they're very smart creatures. And it would be the most powerful computer we would have ever built. But 18 years ago, it was impossible. About 12 years ago, there was a new paradigm in this technology that allows us to model hundreds of millions of neurons, and we can teach these brains to do things that traditionally only human beings can do. That's what people are calling deep learning or deep neural networks. Everybody's excited about it. I would argue that these brains are very good at knowing things about the world. They're very good at extracting patterns. They know that that's a chair and she's happy and he's sad. But these things are not good at making decisions. You need to use these to extract insights from the world. You need to use these technologies to then reason and make decisions to achieve your goal. And then you need to build systems that can adapt themselves in production. And this is a very complex and hard thing to do. That's where it gets a little bit philosophical. So if this is the bounds of human ability, I would argue that we can take any specific task that a human does, and we can probably build an AI that can outperform human at that specific task, significantly outperform at that specific task. But it's very expensive and complex to build individual systems that solve individual problems. So there's lots of interesting research going into what is called artificial general intelligence. And this is where you have one brain, one system that can do many things. And actually, this is why humans are very special. We are one system that can do many things, and we are incredibly adaptive. We actually are very, very special. But if we take this idea to its extreme, it's predicted that within our lifetime, we are going to build a brain smarter than us in every single possible way. This is the last invention that humanity will create. It could be the most glorious thing that happens to us, or it could be our biggest existential threat. I think it's our biggest existential threat, trying to figure out how to mitigate this risk, and it's predicted to happen within our lifetime. Before we build super intelligences, we're having to build systems that make decisions about our everyday lives. Just land then. Wait until I tell you about us living in a simulation created by a super intelligence in a different universe. But that's a different conversation. So anyway, before we build super intelligences, we're having to build systems that make decisions about our everyday lives. And so you've seen this problem before. It's called a trolley problem. I'm in my driverless car. In front of me is a kid. To the right are 2 adults, and to the left is a cliff. The car can't stop. Who does the car kill? So I know most of you are looking down at your laptops, but put your hand up if you would kill the kid. Okay, 1, good. And that's all right, it's good. It killed 2 adults. 1, 2, a few people, and killed you. Okay, a few people, okay. Actually, that's more lively than I thought it would be. Most people don't put their hands up, and it's because philosophers for 3,000 years have been arguing about this stuff and still can't come to a conclusion. But what's exciting about this time in human history is we're having to build these decision-making systems in systems that are making decisions about our everyday lives. By the way, this is what people are currently calling AI ethics. I controversially would argue there is no such thing as AI ethics. I know that everybody's getting worked up about this concept. If you go to an AI ethicist and say, are you an ethicist? They get embarrassed very, very quickly because they're not really ethicists. And most of the challenges that we're dealing with in AI are not ethical problems. Ethics is the study of right and wrong. And right and wrong stems from the interrogation of the intent. AIs don't create the intent. Human beings create the intent. You create the intent. You say, my intention is to maximize revenues. My intention is to route my vehicles more efficiently. My intention is to allocate my staff to maximize my utilization. You create the intent. The AI then tries to figure out how to achieve your intent. It's not making any ethical decisions. Where it goes wrong, where it's biased, where it makes mistakes, those are safety problems. I won't go and rant about this, but there's too much emphasis on AI ethics. There is such thing as AI ethics, but these are questions like, if we build a sentient machine, do we have the right to turn it off? Right? These are not questions for business. These are questions for academics and philosophers. Anyway, most AI projects fail not because of ethical reasons or even safety reasons. They fail for the same reasons why software projects fail, because they're under-resourced, they've got the wrong skills on them, they haven't thought about how they're going to be supported and maintained and all of that boring stuff. So don't get seduced by consultancies trying to sell you fear-mongering around AI ethics. All right, let's talk about innovation. So I don't know if you can see this, but this is a hierarchy. And hierarchies breed certain types of interesting relationships. This is not a picture of my company, although most people do sell drugs to each other. That's quite common in my company. And I would argue that these structures are not conducive for innovation. They're not conducive for adapting your organization to a rapidly changing world. So over the past decade and the next decade, we're embracing new types of organizational paradigms, agile and scrum and design thinking and all these things. And the principle behind these things is adaptation. How quickly can we adapt to an ever-changing world? And this is a whole different talk, but there's a whole load of trends that are happening in organizational design structure to move organizations from rigid structures to much more adaptive, fluid structures. I'll touch upon a few of these. I should also say that whilst, yes, we could use AI to sell more stuff, right? And that's my day job, and we can use AI to optimize supply chains and all that kind of stuff. If you're not using AI to reinvent how you are organizing yourself as a company, you are going to lose talent and you're dying from the inside. And we can sell stuff, and we can So I think it's really important that we look internally at how to unlock the creative capacity of our employees to innovate. In fact, this technology stack that I just talked about is going to be a commodity over the next decade. We already have cheap compute and lots of data. All of the data science tools you need are free. They're all open source. Go and download them. Somebody will commoditize decision-making and self-learning, probably Satalia. The battleground for talent, battleground for companies is not technology, it's talent. We all know that. How do we attract, retain, motivate talent and get them to be able to innovate? The faster we can innovate, the more quickly we can adapt to a changing world, the more intelligent we are. And Steve Jobs had a very good definition for innovation. He said, innovation is creativity that ships. The most important word in that definition is the word that. That is the process of getting ideas to the point where somebody's willing to pay for them. And that process is long and hard and painful. And our job is to figure out how to shorten that process. Anyway, the key ingredient to innovation is motivation. A very good introductory book by a guy called Dan Pink on motivation. He says there are three things that motivate people: autonomy, mastery, and purpose. Autonomy is giving people the freedom to do what they want. Mastery is giving them the ability to become really good at what they want. And purpose is giving them something higher to align themselves with. And I guess over the past, the first challenge that organizations have is, how do you attract talent in the first place? The number of CEOs that have said, here's £1 million, go and build me an AI team. They can't hire a single person because if you ask yourself, how sexy is my industry or my brand, and how interesting or challenging are your problems, most companies are not sexy, don't have interesting problems, they're not going to attract talent. If you're sexy and you've got interesting talent, you'll attract talent and they'll stick most likely. And if you're in the other two quadrants, you'll attract talent and they'll leave after a few years. And that actually can be more dangerous to your company than not being able to attract talent at all. So knowing where you are on this matrix will help you understand whether you work with third-party vendors or you hire your own team or you use technology off the shelf. But once you have engaged with talent, you then need to create a culture that enables that talent to thrive. And over the past decade or two, we've seen a flattening of organizations, new tools and technologies and organizational structures remove middle managers, creating these flat or thin companies. And whilst I think that's a good step in the right direction, I still think this is not conducive for innovation. My company was only about 120 people before it was bought by WPP. But we've never had any managers, any hierarchies, any KPIs. People have always been free to work where they want, however they want, wherever they want. We operate like a swarm. And in fact, what I'm interested in is building an operating system that allows for the right structure to emerge according to the innovation that needs to get taken to market, whether a service or a product or an asset. And actually, my goal is not just to scale that swarm or liquid operating system across WPP. My goal is to scale it to a planet. I want to try and create a planet where everybody can work where they want, how they want, whatever they want, and be fairly remunerated for their contribution. One enabler of these types of fluid or liquid organizations is a thing called organizational network analysis. So we pull together all of the data across our organization, all of our Slack data, the email data, all of the code repositories, to try and get these pictures of the relationships between people, what their skills are, what their hopes and dreams are. And I can identify people who are going to leave the company before they know they're going to leave the company. I can identify secret lovers in my company, the people that sell drugs to each other. This obviously does also raise lots of interesting ethical questions. But the principle behind this is that we're able to identify the people who can be best allocated to not just increasing utilization, but how can they be allocated to work that aligns with their values, the values of the customer, and so on. And so these types of technologies are enabling liquid organizations. Just to give you an idea of the crazy things that we used to do. So we used to get everybody to make public recommendations of their salary. So everybody would declare what they want to be paid, and then people would vote on whether their salary should be increased or decreased or kept the same. And we would use machine learning or AI to determine how many votes one person has for another. So if I've worked very closely with you, I'll have more votes for your salary than somebody else. So I had interns voting on people's salaries that had more weighting than me. And I believe that we can use this type of weighted decision making for any type of decision in the company, whether it's financial forecasting or hiring or firing or resourcing. Rather than using the hierarchy to make decisions, we can identify who's the best group of people to make that decision and empower them. This is the future of how organizations will operate. This is also a concept called digital twins that I won't bore you with, but after digital transformation, which is getting your data together, the next big step is, how do I join marketing to supply? So at the moment, if you create a campaign that drives 20% more demand, can your supply chain fulfill it? You probably don't know. And you're only going to be able to do that if you can create a simulation of your organization. If I can generate a marketing campaign over here that creates 20% more demand, will I have the right number of racks in my warehouse? Will I be able to get my suppliers to be able to provide me the resources? Will I have enough people in my stores to sell that stuff? Unless you can connect all of that together, it's going to be very, very difficult. So the interesting thing is that you can identify opportunities within the supply chain. You can say, I've got a supplier giving me some cheap goods. I've got some spare space in my warehouse. I've got some extra people allocated to some deliveries. How do I then use that to drive micro-marketing campaigns? So one of the most powerful enablers of a digital twin is to be able to have supply inform marketing instead of marketing just inform supply. Let's talk about the future very, very quickly. Hopefully, I've somewhat convinced you that there's a lot of misunderstanding about AI. And hopefully, I've convinced you a little bit that if you invest in it right now, if you invest in architecting yourself for adaptation, then that's a very powerful position to be in. Because if you can adapt more quickly than the startups that are coming along, adapt more quickly than your competitors, in theory, you won't ever die. And I don't know if anybody knows who said this at the top here, but the nation that leads in AI will be the ruler of the world. Does anybody know who said that? Vladimir Putin recently, actually, a group of children, I think. But anyway, I think we need to acknowledge that this is incredibly, incredibly powerful technology. It's probably overhyped at the moment, but the impact that it will have on society in the long term is massive. And I've tried to capture in this framework that I'm sure you're all aware of the macro impacts to society. So, and I think that this industry has to play a significant part in making sure that we steer this in the right direction. So, I've alluded to the concept of a singularity. A singularity is a point in time that you can't see beyond. I've talked about the idea of us building a brain that's smarter than us in every single possible way. And we have no idea what's going to happen. It's often referred to as being the technological singularity, but I think there are 6 singularities, and I'm trying to use this kind of macro framework to capture them. So the first one is political. This is when we no longer know what is true. So deep fakes, fake news, misinformation. This is accelerating a divergence, a polarization, a manipulation of people. And in fact, actually, I heard recently that the machine learning model was trained on the voice of a CEO, and they got the machine learning model to call up the accounts department to pay an invoice, and they thought they were talking to the CEO. But there's a point in time where society no longer can trust the content that it's engaging with, and I think that is a very scary place. It's already challenging our political foundations, it will also start to challenge the fabric of our reality. And that will be also accelerated by the metaverse. When you're in the metaverse, you have no idea whether that's a real person or the person that you're meant to be speaking to. The second singularity was actually coined by a very good friend of mine, and this is around job losses. And one of the reasons why WPP acquired us is because we can use AI to improve the effectiveness of how marketing works. And the concern is that you can remove tasks from people and free them up to do more interesting things. But if you can, the pressure to reduce costs in a company means that if you can remove whole jobs, you will. And the concern here is that over the next 15 years, we are going to have or see mass technological unemployment. And our society is not set up to deal with that amount of social unrest. People have said in every industrial revolution, we've always come up with new jobs. People have been able to retrain. The reason why I think this is different is because if you create paid work, you'll probably be able to build an AI that can do that work better and faster than a human being. So you won't be able to retrain to get new jobs. I actually controversially think we should be accelerating automation. So hear me out, but in theory, AI can remove the friction from the creation and dissemination of goods. And it can remove the friction so much that the cost of them almost becomes zero. I was talking to a taxi driver yesterday, and he was saying he was worried about his jobs and he was worried about job losses. If you remove the labor from taxis, the cost of a taxi ride would become very, very cheap. So if you can remove the friction, the cost out of the creation and dissemination of goods, you can make goods abundant. Our food, our healthcare, our education, our nutrition, our energy. And I think there's a world that we can create where people are born into that don't have to worry about working to feed themselves or house themselves or pay for education. I think there's a world of abundance, freeing them up economically to go and do whatever they want. But we have to get the timing right, otherwise we're screwed. Anyway, the third singularity is when we cure death. There are scientists that believe there are people alive today that don't have to die. And this is where AI can accelerate medicine. It can clean us out and make sure that we're not creating anything that becomes chronic. And this will change how society operates. Technological singularity I've already alluded to, which is where we build a super intelligence. I'm worried that when this thing comes, which is in the next 20, 30, 40 years, maybe even less, that if we're still fighting each other over GDP and resources, it's probably going to see us as a threat and remove us from the equation. I think that would be sad, because I think humans are cool. So we've got 40 years to figure out how do we get humanity cooperating as a species. That's our task. The environmental singularity you're all familiar with, which is consumption, which is one of the things that we drive in this industry, is consumption's good on the one hand, because it's getting stuff to people that's enriching their lives. But it's also putting pressures on our planetary boundaries, and the concern is that will create uncontrollable ecological collapse. I think that technology will play a massive role in solving that. And the final singularity, again, linked to this industry, is where surveillance becomes ubiquitous. One might argue there are companies or governments that not only know so much about you, but also have the ability to manipulate your decision-making to benefit themselves. And that's an incredibly powerful position to be in. We might already be living in this singularity, we might just not know about it. And I think we need to mitigate the consolidation of that power and manipulation. So I'm just going to close and say that if you want to attract talent and customers, it's not just good enough to have a sustainable, profitable business. You need to have a strong purpose. And I think we've all heard this to death. But if you've got a strong purpose, you're going to attract talent and you're going to attract customers. And we help our clients amplify their purpose, because they realize if they want clients, if they want customers, if they want talent, they need to be purposeful. And actually, I don't have any faith that governments are going to create these glorious futures for us. Actually, I think the industry, enterprise, the collective purpose of all of these companies are actually going to create these glorious futures. And I think it's partly our job, this industry's job, to make sure that we're steering them in that direction. My purpose is to enable everybody to live beyond themselves. How do we create a world where everybody has access to an abundance, giving them the freedom to go and do whatever they want, unlocking the creative capacity of humanity? And I want to work with as many people as possible to create that reality. I think on that, I'll stop. Any questions? I didn't talk about marketing or anything, did I? Probably want to hear about that. I can tell you all the things that we're doing in WPP and all that kind of stuff. You all know that stuff. You've heard it all over the past 2 days. Happy to answer the questions about that if you want.
Hi. So again, thanks. This was pretty crazy. but I think we can all agree very entertaining. Uh, right. So yeah, my questions you already touched upon that, basically saying that whenever people in companies say that, hey, we have this crazy AI, right? It's never really AI. From your experience and in your daily work, how much of it really is close to being AI, and how much of it is just linear regression and half done, neural networks and stuff like that.
It's a good question. Okay, I'm going to lose half of you here, so sorry about this. But so all of
Yeah,
these
I'm
definitions
here.
of
I'm
AI
here.
are
So
all useless, like narrow AI, strong AI, even the goal-directed adaptive stuff useless, because everything that we're doing in industries is not any of that stuff. So that actually, I think of it from an applications perspective, and there are 5 categories of application of these technologies that need to be looked at differently. So the first category is automation. So we can automate simple tasks, human tasks. And we're already doing that with Excel and macros and things like that. And there's a whole body of new technologies that allow us to automate tasks, simple tasks, very efficiently. So automation. The second is, might be interesting to listen to, is generation. So we can now generate text, images, videos using AI. And each one of these, by the way, have interesting ethical and safety questions. So you can see the bias that's coming out of DALL-E and people then trying to mitigate some of that bias. But there's the generation of content. And again, that's text or video or whatever. The third is the humanization of the interface. So what I mean by that is that we can create avatars now that look human. We can create chatbots that we think are human. And again, there are interesting ethical questions you need. Should we declare? I have to declare that I'm a human when I'm on the internet. Should we get bots to declare that they're bots? Should we? So I think that so that's the third category is the replacing the human interface with something that looks like human. The fourth one is what I guess people are calling machine learning, but it's extracting insights from lots and lots of data and helping us understand and explain the world that no human is ever going to be able to do. So that's a whole set of technologies, and then there's another set of technologies around decision making. So how do I allocate my resources? So those are actually broadly the 5 applications of AI. Each one of them raise different questions, different concerns, and I think that most people kind of convolute them or don't even understand all of them. So that I don't know if that answers your question. And that those are the 5 lenses that I look through when seeing what are the right technologies to apply to the problem that I'm seeing. So I know that most things that people are doing in industry don't align with the definitions that I've covered, but they do touch upon those 5 categories. And new technologies over the past 15 years mean that we're able to do some interesting things in those 5 categories. More questions?
yeah, I got another one actually. might as well, So let's help marketing people out here, because I'm one of the marketers as well. So let's just help out. So some of the AI or some of these applications, marketers get to experience day to day. And can you maybe kind of comment or touch upon this kind of trust issues and the ethical and the trust part of, let's say, trusting a Google algorithm, trusting Facebook, trusting LinkedIn, trusting, because someone built it. Obviously, there are some, safety and, concerns, etc. So how should marketers, should they build their own thing? Should they look at their own stuff, or how to mitigate those risks?
So that's a really good question. So let's just remember, separate out ethical questions and safety problems. If I'm using a tool or built a tool that doesn't behave how I want it to behave, it's probably a safety problem. Have I tested it properly? Have I created the different scenarios where that I want to mitigate? If I create, but the intent should be scrutinized from an ethics perspective, and there's already ethics committees, standards that are set up. Let me give you an example. So imagine I'm on the ethics committee of a ride-hailing company, and we deploy an algorithm that takes lots of data, your past data, the current weather, your battery data, and then tries to set search prices, okay, which they do. And what the algorithm realizes is that when your battery is very low, you're willing to spend more money. And so what it's done is it's identified an exploiting a vulnerability. You are vulnerable, your battery is low, and I'm going to exploit that. Now, AI didn't know it was exploiting that. All it's found is a correlation between you spending more money on your battery. You, as a marketer or on the ethics committee, need to decide whether you're happy with that. Am I happy that they're going to use battery data, or people in vulnerable positions can get them to spend more money? And you might say, no, I'm not happy. I'm going to either exclude battery data from the algorithm, so it doesn't have that bias or effect, or I'm going to use battery data to prioritize lives because you're vulnerable. Yay, it's a good thing. Or to find cars that have a charger for you. So it's the intended use of the data, it's the intended use of the AI that's important. And the challenge is, how do you surface where it's going wrong so that you can mitigate those risks? The problem with AI at the moment is we're putting systems into production without thinking about the consequences, and these systems can perform amazingly. They can really move the needle in terms of what you want to achieve, and sometimes that can really harm people and harm organizations. So I think we need to put more emphasis around ensuring that these systems are safe, and we'll see more and more over the next 5 years examples where these systems go wrong, and it will force regulators to put more assurance around them. In fact, unfortunately, what we're going to see from the AI EU Act is the AI EU Act is going to be coming down the line soon, and it's going to be asking organizations to ensure that their algorithms are assured and transparent and auditable, but they don't know what AI is. So if you've got an Excel macro, you have to now assure it. And so to give the language, it's going to be a shit show, because there's a misunderstanding of what these technologies are. But I think the spirit is there. It's just not going to be implementable. But we do need to be careful about how these technologies are being used. So I know you were worried about the superintelligence. And just to close that off, there's a concept called, I'll close now. There's a concept called the Fermi paradox. This is where you might need a glass of wine. There's a concept called the Fermi paradox, which is if the universe is 14 billion years old, and the mathematical likelihood of there being intelligent life in our universe is very high. Mathematical likelihood of that intelligent life creating a superintelligence like we will soon, like a silicon god, is also quite high. And the paradox is that when we look into the night sky, we should see evidence of some sort of life. We should see some sort of pattern of superintelligence, and we don't. And that's the paradox. And the hypothesis is that we are living in a simulation created by a superintelligence in a different universe, and there's a 1 in a billion chance that this is not a simulation. So in quantum physics, there are some examples in quantum physics that suggest that this is a computer simulation. Leave it there. Leave it there. All right. All right, shall I go now? Yes. Okay, I'm good. Thank you.